We're continuing our sum and difference identities, today discussing the sum and difference identity for tangent. Going through a couple of examples, I'll discuss what it means to prove with identities, and then you'll see your third example. Sum and difference identity for tangent. Again, we have both the sum and difference versions. In the sum version, we will get, so if it's sum, we'll get a plus on the numerator and a minus on the denominator. If it's a difference, it'll be minus in the numerator, positive on the denominator. So this one matches, this one's the same, and this one's the opposite sign. To find the exact value of tangent of 15 degrees without using a calculator, we're going to find the difference of 45 degrees, tangent of 45 degrees and 30 degrees. So when I plug all of that into the identity, we get the tangent of 45 minus the tangent of 30 all over 1 plus tangent of 45 now times the tangent of 30. Tangent of 45 is equal to 1. Tangent at 30 degrees is equal to root 3 over 3. So evaluating the identity, we get 1 minus root 3 over 3 all over 1 plus 1 times root 3 over 3. We need to now get common denominators in both the numerator and denominator of our big fraction. So I'm going to multiply this side by 3 over 3 and this one by 3 over 3 so that we get 3 minus root 3 over 3 all over 3 plus root 3 over 3. And if you multiply by the reciprocal, you would notice that the denominators both cancel out, which gives us our final answer of 3 minus root 3 over 3 plus root 3. Working backwards, if this is the equation that we're given, or the expression, we can see that it must be a difference identity, so it must be the tangent of 75 minus 30, which simplifies to the tangent of 45 degrees, which we already talked about in the last slide, is equal to 1. So the exact value of this expression is 1. I'm not going to do the last example, I'm just going to do these two. If we're being asked to prove an identity, what we're being asked to show is that both sides of the equation balance. So by using identities to rearrange usually the more complicated side, we can show that it matches the already simplified side. So I'll start off with this first one. If we take the sine of x plus pi, we want to show that that equals negative sine of x. So what I'm going to do is use my sum identity for sine and simplify it to see if I can get negative sine of x. This doesn't look helpful at first because we can't evaluate the sine of x, but we can evaluate the cosine of pi. The cosine of pi is negative 1. And the sine of pi, similarly, over on this side, we don't know what cosine of x is, but the sine of pi is 0. So this term cancels out, and we're left with negative sine of x, which shows that the two sides of the equation balance. Therefore, we've proven the identity. You should jot that down because I'm about to erase the slide. Taking the second identity to prove, we're going to use the sum of cosine. Remember to use the opposite sign in between the two terms. Sorry, I ran out of room there. I can't evaluate cosine of x or sine of x, but I can evaluate the other parts of the term. So we still have cosine of x, but the cosine of 3 pi over 2 is 0. We don't know sine of x, but sine of 3 pi over 0 is negative 1. The cosine x times 0 cancels out. Negative times a negative is a positive, so we are left with positive sine of x. So we have balanced the equation, which means we have proven the identity. So those are the examples. If you have any questions for me, make sure you've jotted them down and you'll remember them when you get to class. And make sure you're asking me these right away. I want to clarify anything that didn't make sense in the video before you start working on your work or I give you a homework quiz.